maybe that screen is not visible. Good morning to all. Am I audible?
Yes, sir.
Is my slide is visible to all of you?
Yes, sir.
Yeah, okay, thank you. So today we'll talk about explainable AI for medical signal. Assistant professor at NIT Puducherry, Karaikal. And why this explainability is coming into picture. This is my plan of talk. Basically, I will talk a few points related to this machine learning as well as deep learning, and we'll see the importance of explainable AI for particularly cardiac disorders. Before starting this explainable AI, I want to give introduction about what is called your learning. Basically, this represents the process that leads to change and result of experience and increases the potential for improved performance and future learning. So whenever we are learning something, we have to look into that. The performance has to improve in future. So this learning concept can be implemented to the machines. As we are learning, all the living animals, living beings are learning. Similarly, how this learning can be incorporated to the machines. And that's why the concept starts that is known as the artificial intelligence. So this artificial intelligence tells how the computer could made to think, or we can say in other way that is effort to automate intellectual tasks performed by the humans. So the main component of this artificial intelligence is nothing but the neural network, and which tells the interconnection of the networks and the processing units is known as the artificial neurons, and this can behave the similar way as the human brain is behaving. That means the neurons are interconnected and do the work the similar manner how the human brain is acting. So this AI, artificial intelligence in clinical development, it's the recent challenges as well as it has to be used for the betterment of the human beings. So how this AI can be used in case of medical applications? If we look into this cycle, that is monitor, analyze, plan, and execute. So this is the cycle which is basically used for the medical domain in case of artificial intelligence. In this cycle, there are some sensors are present, and the most important part of the sensor to acquire the data, and this data has to be monitored. This data has to be monitored and it has to be analyzed. How the data can be analyzed? This can be analyzed by extracting the features, and these features are extracted. This will be executed by the certain kind of classifiers, and based on the classifier, so this executor will perform some output, and this output is nothing but some decisions or some kind of effectors. So if we'll say this in medical domain, by using AI requires the four blocks that is known as the monitor, analyze, plan, and execute. If we look into these four parts or the four blocks, the most important thing is known as the knowledge. So based on the knowledge, this artificial intelligence will work out. So that means based on the sensor data, the information has to be analyzed by considering the knowledge from the environment or knowledge from these databases, and to provide one output that is known as the effectors. So this cycle requires the landscape of AI. So basically, this landscape of AI is not only a one science, it is the constitute of some different sciences. And basically, this landscape is nothing but the evolution of complex future of the state of artificial intelligence. It provides a blend of data, the technique that is used, as well as the analytics, as well as the knowledge that has been used. So if we look into this landscape of AI, it is not only one science, rather it is consist of some 11 sciences which built one over the other. If we look into this diagram, then we can see that suppose I will take the case of artificial intelligence. It is not only one branch of science, rather it consists of some other branches of science like automated reasoning, a branch of computer science, a branch of neural net or artificial neural nets, etc. Again, if we look into the another branch of science which is interlinked with artificial intelligence, then again it is interact with some other sciences. So if we look into this AI is nothing but consist of 11 sciences which is built one over the other, or one is depending upon the others. So first we have started with our journey, the learning, and the most important is nothing but the artificial intelligence. And we are talking about that how artificially we can become the intelligent like the human brain. So one of the most important thing is known as the machine learning, which tells about the branch of AI that consists of certain algorithms as well as the statistical models fixed task by the help of the machines. So how this machine learning algorithm can work out, or how the machine learning algorithm will perform its task. Basically, this machine learning can able to learn from the database or that from the environment. So what exactly this machine learning algorithm says? Basically, it is nothing but a computer program that can learn from the experience with respect to a task, such a manner that the performance has to improve with respect to the experience. That means we can say that a computer or a machine can able to learn from the database or from the experience to perform a task or to perform a work, and the work has to be done in such a manner that the performance has to improve with respect to the experience. So there are various kind of learning is present in the future slides. We'll have a look into those. So if we'll take one best example, that is the robot able to walk. So that means what is this walk? This walk is nothing but a task. That means walking is the task. But how we can able to make the robot to walk, that is nothing but the manually known as the learning. So how we can learn, or how we can train the machines? So basically, this machine can able to learn or can be trained from the experience. And what exactly the experience represent? The experience represent the databases. So the famous database and popular database that is known as the iris database, which consists of 150 different iris plants, and these 150 different iris plants are separated based on certain features, and these features are known as sepal length, sepal width, petal length, as well as the petal width. So we can say that the experience is nothing but the database, and we are getting the experience from the databases. So based on this experience, this machine learning algorithm are mainly grouped into supervised as well as unsupervised learning algorithms. If we look into the supervised learning algorithm, which consists of the annotations, that means the annotations are present in case of supervised learning, and there is no annotation in case of unsupervised learning. So the best example of the supervised learning, how the warrior, the greatest warrior Arjun has learned the skills from his teacher, that is Guru Dronacharya. And unsupervised learning is the best example that how the great warrior Ekalavya has learned from his Guru Dronacharya is known as the unsupervised learning. That means in case of unsupervised learning, there is no annotation is present, whereas in case of supervised, the annotations are associated with it. But in case of semi-supervised learning and self-supervised learning are the learning algorithms which are derived from the supervised as well as unsupervised learning algorithms. In case of semi-supervised, a few of the data are labeled and few of the data are not labeled. The most important application of this is nothing but the generative adversarial network, in which the few of the labeled data have been used to generate the unlabeled or to generate the few more labeled data. And basically, another is called the self-supervised learning. In self-supervised learning, automatically we can learn, and one of the best example of this category is known as the autoencoder, and which performs the similar action to that of the data compression. And next one is the reinforcement learning, and basically this reinforcement learning makes the work much more simpler as well as the faster. It works on the principle of the feedback concept as well as the maximizing the reward. So that means this reinforcement learning, taking a feedback from the environment, and based on the feedback, it has to perform a task such a manner that the reward is get maximized. And one of the best example of this reinforcement learning is nothing but the automatic driving car. So the automatic driving car has to move ahead, or it has to take a left turn or a right turn, or it has to stop. That depends upon the surrounding condition. So that means this reinforcement learning take a decision based on the surrounding such that the reward is get maximized. And the transfer learning is the concept where the transfer or the learning is information, or the is get transferred to do a learning task, and basically this is used for a lesser amount of data. So these are the basic classification of these learning algorithms. So why this deep learning concept came, and what are the challenges that we are facing with this deep neural network, and that's why you are going for the explainability or explainable AI. So for that reason, we should understand the evolution of this artificial neural network and where exactly the bottleneck happens, such that we are going for one neural network to another neural network. If we look into the history, in 1943, Warren McLeod as well as Walter Pitts developed the binary threshold neurons. And in 1957, Frank Roosevelt invented the perceptron, which basically is a linear classifier or linearly separable classifier. It can able to separate linearly separable data. In 1960, Minsky Puppet showed the limitation of the perceptron. The most important limitation of the perceptron is that it can able to separate the linearly separable data, but it cannot able to separate the non-linearly separable data. So the non-linearly separable data cannot be separated by the perceptron is the limitations. And from 1960 to 1980, there is a winter break. There is no more significant research in the field of neural network. In 1980, Geoffrey Hilton, David Rimalhat revived this artificial neural network and invented the backpropagation algorithm for multi-layer perceptron. And we'll understand what exactly this multi-layer perceptron is doing and how this multi-layer perceptron can improve the classification accuracy, or can able to make a non-linearly separable classes to a linearly separable classes. In 1990, support vector machine was invented by Pavliks, and it became very famous in case of a neural network. And in 2006, artificial neural network is renamed as deep learning because of this deep belief network as well as the unsupervised pre-training. And 2010, the ImageNet was developed. 2012, Alex Illa and Geoffrey Hilton owned the ImageNet computation by using this ReLU activation function as well as a huge, that means using deep learning by a huge margin of dropout regularizations. So this is the evolution of this artificial neural network, and this artificial neural network becomes equal to the deep learning, or that is the deep neural network. So you'll understand what exactly the perceptron is and what exactly the limitation of the perceptron. To understand this, here I have taken one example of a two-input logical OR gate. And in case of a two-input logical OR gate, there are two inputs are present and one output is present. So if we represent the input-output relationship by the help of a truth table, then a two-input logical OR gate produces the output is equal to 0 when both the inputs are 0, and rest of the combination, the output is equal to 1. So in this case, there are two classes are present. One class is 0 and another class is 1. So my aim is to separate the output 0 from 1 by the help of the neural network. So how this can be achieved? In order to represent this, or in order to perform this action, this input and output relationship is represented by a graphical representation by certain black as well as red dots. For 0, 0, the output is 0. It is represented by a black dot, and the rest of the combination, that is 0, 1, 1, 1, and 1, 0, are the output is equal to 1, which are represented by the red dots. So I can able to separate the output that is 0 class from the 1 class by using a straight line. So if you look into the straight line, this straight line is depending upon certain parameters, that is W1, X1, W2, X2, as well as the bias. So in this case, indeed X1 and X2 are known to me, and what are the unknown quantities, that is equal to W1 and W2 and the bias. So if I'll choose this W1 and W2, which are nothing but the weights, as 1.0 and 1.0, and bias is equal to minus 0.5. So when I will substitute X1 and X2, that 0, 0, then this output will become equal to negative. And when I will substitute rest of the combination, that is equal to 0, 1, 1, 0, and 1, 1, I'm getting the output is equal to positive. So that means for 0, 0 combination, the output is negative, and for rest of the combination, the output is positive. By using a threshold, I can able to separate the output of a 2-input OR gate. That means 0 from the 1. So if you want to represent it by the help of a neural network representations, by taking this neuron as a input 1, this neuron is input 2, and this is my output neuron, and each neuron is associated with a weight that is equal to W1 and W2. So W1 X1 plus W2 X2 plus the bias is associated at here, so that is equal to Y. So Y can be represented as W1 X1 plus W2 X2 plus bias. So this is represented by the simplest neural network architecture, that is known as the perceptron. So the perceptron can able to separate the linearly separable classes. That means the zeros and ones of a 2-input OR gate are separated. The same thing is happening in case of a 2-input logical AND gate. So what will happen in case of a 2-input exclusive OR gate? In case of a 2-input exclusive OR gate, the output is equal to 0 when both the inputs are identical. That is 0, 0, output is equal to 0, and 1, 1, the output is equal to 0. But rest of the combination, that is 0, 1 and 1, 0, the output is equal to 1. So how we can able to separate the output that is equal to 0 from the 1 by the help of a perceptron? So in order to separate it, we cannot able to do the separation by the help of a single straight line. If we look into the graphical representation, 0, 0, that is equal to represented by black, that is 0, 1, 1, that is represented by black, that is also 0. For rest of the combination, 0, 1 and 1, 0, the output is equal to 1. So it is very difficult to separate the output of a 2-input exclusive OR gate by the help of a single straight line. In order to separate this, we require 2 straight lines. So this is the one example where the output is whereas the classes are not linearly separable. That means this is nothing but a non-linearly separable data. So how we can able to make a non-linearly separable data to a linearly separable data? So that's why the concept of neural network or multi-layer neural network is coming into picture. This can be done by the help of transformation. This can be done by the help of certain activation functions. So we'll just understand this, and these activation functions, these transformations basically introduces another layer to the neural network, and which makes the neural network to be a multi-layer neural network. So now we'll just see this example of this radial basis function, which is nothing but a transformation which makes a non-separable problem to a separable problem. That means this is performed by the help of increasing the dimensionality of the data. So how the dimensionality of the data can be increased? Basically, this radial basis function consists of a receptor, and this, as we are moving away from the receptor, the value is increases or decreases. How this radial basis function is basically what this radial basis function is performing? This radial basis function maps the input x into the output that is equal to phi of x. Here, for simplicity and ease of understanding, this Gaussian basis function is considered that is equal to e to the power x minus t norm square. So if we recall our 2-input exclusive OR gate, then this is the graphical representation of the output of a 2-input exclusive OR gate. So in this case, 4 receptors have been considered, T1, T2, T3, as well as T4. As we are moving away from any of the receptor, the value of this radial basis function will either increase or decrease. If we look into this diagrammatical representation, then we can see that T2 and T3 are equidistant from T1. Similarly, T2 is equidistant from T4 and T1. Similarly, T2 and T3 are equidistant from T4. So that means this is a symmetrical representation. So in this case, we can calculate the standard deviation, that is equal to sigma is equal to 1 square plus 1 square divided by 2. So that is equal to 1, which is nothing but the root mean square distance. So we can calculate what is the value of phi, that is called the radial basis function, corresponding to each receptor. So that is phi 1 for corresponding to T1, that is equal to 0, 0. We are substituting sigma 1 is equal to 1. So phi 1x is this representation. Similarly, what will be phi 2 for the receptor T2? So we are representing 0, 1. So we are getting this phi 2. Similarly, for phi 3 is computed for T3. This is the representation. So similarly, phi 4 is computed for T4, and this is the representation. So in this case, we are getting the 5 basis functions, that is equal to radial basis functions corresponding to each receptors T1, T2, T3, and T4. So now, how this radial basis function basically behave corresponding to each of the receptors? So we'll get a 4 cross 4 combination, that is called 4 cross 4 matrix. So that means we want to find what is the value of phi 1 corresponding to the receptor 0, 0, 0, 1, 1, 0, and 1, 1. Similarly, for phi 2 for all the inputs. So this will give rise to a 4 cross 4 matrix. If we'll consider this W is for phi 1 is equal to minus 1.0, phi 2 is equal to plus 1.0, phi 3 is equal to plus 1.0, and phi 4 is equal to minus 1.0, and we'll calculate the summation of the multiplication of phi with W, then this will be represented by I is equal to 1 to 4 Wi phi I. So that will give rise to 1.0 into minus 1.0, 0.6 plus 1.0, 0.6 into 1 plus 1.0, 0.4 into minus 1.0, and this summation will give rise to 0.2, that is negative 0.2. Similarly, for all others, we will calculate this is 0 plus 0.2, this is plus 0.2, this is minus 0.2. So what we understood from here? We understood from here is that for the input 0, 0 as well as 1, 1, we are getting a negative value, and for rest of the combination, we are getting a positive value. So by using the simplest threshold, we can able to separate the output of a 2-input exclusive OR gate. So what exactly it is happening? What is the physical significance of this graphical representation or the structure of the neural network? Basically, this radial basis function maps the 2D feature vector into a 4D feature vector. So how it can be represented? So this can be represented by introducing another layer into the neural network, and this basically increases the number of layers into the neural network. So in this case, there is a hidden layer which is introduced. So X1, X2 are the inputs, which is represented by the input neurons. So there is a hidden layer which is consists of 4 neurons. That means 2 input is becomes equal to 4D feature vectors. And in this case, the weight that is associated with the hidden layer, that is minus 1, 1, 1, and minus 1, which is represented here. And this will be these are connected to the output neuron, and it will provide the output Y, that is equal to exclusive OR gate output. So in this case, we understood here that the radial basis function increases the dimension of the feature, that means 2D feature vector to 4D feature vector, which can be represented by introducing another layer into the neural network, that is the hidden layer. So the hidden layers, the problem of the perceptron, that is nothing but the non-linearly separable classes cannot be separated by the perceptron, now can be separated by introducing another layer into the neural networks. So whenever this number of layers increases, that means more and more non-linearly separable classes can be separated. So this is the whole idea, that how why we are going for introducing more and more number of layers. Today morning, Professor Krishna Mayapuram told that we are, whenever the database is very limited or very small, or use a very narrow network, that means some low number of or less number of layers to be introduced, and whenever the data is very, very high, you introduce or you use some bigger network. So that's exactly the region where it lies, that whenever the database is very, very high, the data is very, very complex, that means they are more nonlinear in nature. As there is more nonlinear in nature, that means we have to introduce more and more number of layers to make the nonlinearly separable classes to be linearly separable classes. So this same action can be performed by the help of the activation functions. So the most popular activation function that we are using the rectified linear unit, which basically performs, if you look into the term, it is consist of rectified as well as linear. That means it makes all the databases to be positive, and the database will be, output database is a linear representation. So that's why it is known as the rectified linear unit. And people have developed a large number of deep neural network models for different kind of applications. And these are few of the networks that have been represented here. So if you look into these deep neural network models, there are mainly of convolutional neural network, recurrent neural network, stacked autoencoders, deep Boltzmann machine, as well as deep reinforcement learning networks. So these are the few classification of these deep neural network models. So I'm not going through these things. So as we have discussed, that is artificial intelligence, machine learning, as well as deep learning. So here is the nomenclatures have been given for artificial intelligence. That is any technique that enables computers to mimic the human behavior is known as the artificial intelligence. And this machine learning is a subset of this artificial intelligence, which tells about the computation of a multi-layer neural network to be feasible. The machine learning, that is nothing but to give the computers the ability to learn without being explicitly programmed to do such. And the deep learning is a subset of this machine learning, which tells about the computation of a multi-layer neural network to be made feasible. So I can say that this deep learning is a subset of machine learning, and machine learning is a subset of this artificial intelligence. And if we compare this deep learning as well as machine learning, we can say that this machine learning requires the feature extraction, whereas the deep learning doesn't require any feature extraction techniques. So now we are talking about the deep learning, and this deep learning just like behaves like a black box. That means what features basically it is extracting, how many number of features it is extracting. This looks like a black box nature. So there is a limitation of this deep neural network concept. So there is a black box issue is coming into picture. So that's why there is a explainable or explainability is coming into picture. So we can summarize here the limitations of AI model is the challenging to the comprehend, as well as it is very difficult to trust due to the black box nature or the black box issues. So the essential component is to understand the reasoning behind the AI model's decision-making ability. And for that reason, this explainable AI is coming into picture. And today morning, Professor told there are many models, LIME, GradCam++ have been used to explain the nature of the layers, that how many number of layers to be used, what kind of layers to be, or what kind of batch normalization, or we have to go for some other process to overcome the overfitting conditions. So this explainable in this particular session, we'll talk about what is the background of XI, as well as what is the common definitions. We'll summarize one of the technique and how we are using the explainable AI for our work. Basically, if you look into the literature, so this explainable AI is represented by data explainability, model explainability, post-hoc explainability, as well as assessment explainability. So we'll talk about that how explainable AI will basically can be used. So these are some of the applications. I'm just skipping those slides. So as we are talking about explainability, so when we're talking about this deep neural network, it looks like a black box. What is happening inside the box is not known. And if we classify these artificial neural network models, they are mainly categorized into three kind of boxes. One is called white box, gray box, as well as black boxes. And these boxes have to be represented by two terms. That is, one is called the explainability, another is known as the interpretability. So what this explainability basically represent? It represents the decision-making mechanism of this neural network. Basically, this explainability builds a trust, and interpretability basically discloses the internal working principle of the model, and it understands the intrinsic properties of the model by transparency. So we'll just look into this more detail about this white box, gray box, and black boxes. So there are two terms, as I have discussed. One is called the explainability and interpretability. And whenever we are talking about the explainability and interpretability, there is a relationship existing with the accuracy. So if you look into the white box models, basically this inspect the inner logic of the ML model and understand its decision capability, which has the higher explainability but the lower accuracy. And this type of models are not suitable for daily applications. Whereas the gray box models are partially analyzed, the internal working and understanding its decision. It can explain to certain degree, and it has a significant amount of accuracy and can be used for critical application and careful if they are carefully designed. And the black box models could not inspect the inner logic of the model and its decision ability. So this has a lower explainability as well as interpretability and a higher accuracy. And this type of models are not practical to use in case of critical applications. So this is the graphical representations. I'm just skipping these slides. So here there is one trade-off. It's shown between the accuracy versus interpretability. This top line represent the accuracy line, which is from high to low, and the bottom line represent the interpretability, which is representing from low to high. So if you look into the white box models like additive models, GAM, EBM, decision tree, logistic regression, K-means clustering, K-nearest neighborhood, these type of models are high interpretable. They can able to explain the internal working principle of these models very clearly. So, but these type of models have the least accuracy. So if you look into the gray box models like Bayesian network, reversible diffusion based models, diffusion probabilistic models, fuzzy systems, these type of models are coming under the gray box models. They have the medium interpretability as well as medium accuracy. They are not, accuracy is not very high, interpretability is not very high. But whereas the black box models like transformers, GPTs, this MLPs, RNNs, CNNs, LLM models. So these models are having the black box issues, and they are low in interpretable as well as explainability and high in accuracy. So in tomorrow's sessions, one of the professor from IIT Delhi will talk about these LLM models as well as how these LLM models issues can be solved out. So as we have discussed that there is a trade-off between the interpretability and accuracy. If interpretability is very high, then the accuracy is very low. If interpretability is low, then accuracy is very high. So we have to decide a model which can be interpretable as well as provide the accuracy better way. So that's what exactly the research starts, that what are the black box issues and how we can make a solution to this, how we can make a trust on the deep neural network models. And that we are going to discuss, that is known as the black box issues as well as its solutions. As we have discussed, this the ML models are very, very good to provide that good accuracy. So we have to make the trust. That means we have to get the interpretability. We have to make the explainability about these models. So how we can able to get it? So as I have told, the explainability as well as interpretability. So what exactly this explainability basically represents? This explainability provides the insight into the deep neural network's decision to the end user to build a trust that the AI is making a correct and non-biased decision based on the facts. So now we have to explain this model. Now, what is interpretability? It represents enables the developers to delve into models' decision-making process and boost their confidence in understanding where the model gets its result. So this interpretation technique provides an interface that gives the additional information or explanation that are essential for interpreting an AI system's underlying functions. So these are the background studies of XAI, which tells about the different classifiers that can be classified into first category, second category, as well as third categories. So these first categories basically represent to describe the system's internal working process explicitly. So under this category, the fuzzy set systems, artificial and neural networks are coming into picture. The second stage, that is starting human-computer interface that provides the cognitive assistance by focusing on human knowledge and reasoning abilities. Under this category, ML systems are coming. The third category is that mostly black boxes improve the computer technology as well as several novel concepts for producing explainable choices have become more feasible. These are the models that are lack of transparency. So these are some of these applications where people have used this explainable AI. So one of these, Mesak Itala, described the theoretical impact of explainable AI and how to use this explainable AI for these medical settings. And they are using the CNN and the MLP models, identified the sickness, that is the malaria, from the input image as well as thin blood smears. So this is another example where the common XAI techniques using credit card frauds have been detected. So in 2019, Miller et al. Supported explainable AI, including articles from social sciences, that how explainable AI incorporates ideas from the philosophy, cognitive science, as well as social psychology to explain its results as well. So there are some other applications. I'm not going through this. I'm just skipping those slides. So now we'll talk about the concept of the explainability as well as their nomenclatures. What are the nomenclatures are present? Already we have discussed two nomenclatures. One is called explainability as well as interpretability. So except this, there are certain other nomenclatures are present. Greece created a cooperative principle as well as four maximas that to give rise to the explanations to be followed. So whenever we are giving one explanations, this has to follow certain cooperative principles, that is quality, quantity, relation, manner, as well as context oriented. So what exactly this quality basically represents? This quality explanation is good to quality with the following properties. That is, random explanation should be avoided. That means explanation that doesn't have the enough supporting evidence should also be avoided. Next is quantity, deliver the appropriate amount of information in an explanation. Properties, that is known as the explanation, must be informative, provide as much as information as needed. At the same time, do not provide more information that is required. The relation that is existing, that an explanation must contain only information relevant to the discussion. This maximum may be used to improve the quantity of the explanations. The manner how each informative can be delivered. This can be divided into avoid ambiguous languages in the explanation, avoid ambiguity in the explanation, avoid prolixity with a concise explanation, avoid information that is not in order. Context-oriented explanation for developers, regulators, and end users are different. So explainable AI is not a unitary entity. It encompasses several interconnected principles. So there are certain other nomenclatures in case of explainable AI. So one is already we have discussed, explainability, interpretability. The other ones are transparency, fairness, robustness, satisfaction, stability, as well as responsibility. So I'm not going through all these cases. Just I'm talking about the transparency. What is exactly this explainable AI? Represent the transparency. It is essential for assessing the quality of a model's decision and for finding of adversaries. The fairness, it is represent model's ability to make unbiased decision without favoring any population represented in the input data distributions. Biases may affect AI system, location of birth, socio-economical background, as well as the scales. Robustness in explainable AI, it is very sensitive of the system's output to a change of the input and model's capability to function correctly in case of uncertainty. I'm giving one best of the example of this. So that means how the model will behave to a unknown data. That means that the model is initially trained for one set of data. Now how the model is behaving to a unknown data, that basically gives rise to the robustness of the model or the sensitivity. How the model will behave to the noises, also known as the robustness of the model. Computation, subjecting the adversarial inputs to the model and ensuring the system's error rate is near to that during the training process. There is a satisfaction, ability of an explainability technique to improve the usability and utility of the ML-based system. Stability, that is the ability of a procedure to provide a comparable explanation for inputs that are very much similar. Responsibility, building trust and transparency makes the model trustworthy. For deep learning models, be responsible. The following things to be taken into account. One is societal values, morals, as well as ethical considerations. So these are some of the nomenclatures that already we have discussed. And this diagram already we have discussed the trade-off between accuracy versus as well as interpretability. So now, what are the questions we should ask at the several levels to make the explainability and to increase the trust? So there are three type of questions basically can be asked to the model to know about the explainability as well as interpretability issues that is associated with the deep neural network model. One is called the data explainability, model explainability, as well as post-hoc explainability. So what exactly the data explainability? So when we are designing a model for a particular kind of task, let the case of the classification task, so then how the model is behaving to the data. So there are, or in order to understand the explainability of the behavior, explainability of the model, the following questions can be asked and to be answered for this model. What sort of information do you have in the databases? That means what kind of information is present in the database? What can be inferred from this data? That means what is the information that we can be inferred from this data? What are the most important portions of the data? How is the information is distributed inside the data? Is it possible to increase the model's performance by lowering the number of dimensions? So as already in today's morning session, professor told that when we are talking about the cancers classifications, we are not taking a reduced size of the image, we are taking the whole size of the image. Basically, this image in case of cancers, it is known as the whole slide image. It is in the dimension of 10,000 cross 10,000 pixels. So the whole slide image should not be resized, rather it should be cropped into small sections, and it has to be labeled accordingly. So that means, is it possible to increase the model's performance by lowering the number of dimensions, by reducing the sizes? Can the data summarizing techniques offer a better explanations? So these are the few of the questions that has to be asked to the model to understand the data explainability. Similarly, there is a model explainability. When we are designing a model for a particular kind of task, so in order to understand the model's explainability, what makes the parameter or objective or action important for a system? That means today morning professor told, that means we are not changing, that means we are using certain parameters, and that means hyperparameters are changed to get the best result, and they have used some triplet loss functions to get the better result. So what makes a parameter objective or a function is important to the system? So which parameter has to be used, or what objective function or action to be done? When did the system examine a parameter, objective or action? When did the models reject it? That means the model that we have designed, when it will accept the parameter and when it will reject the parameter, and why it is rejecting. What are the consequences of making a different decision or adjusting a parameter? How does the system carry out certain actions? How do these models parameters or objectives or actions correlate or relate to one another? What factors does the system consider or disregard during the decision making in order to achieve a goal or inference? Which techniques does the system utilize or avoid? So in order to understand the model explainability, the following up questions has to be asked to the model to understand or to get the trust about the model. There is a post hoc explainability which need to be answered to understand the interpretability as well as explainability and get a trust on the model. What is the reason behind the model's prediction? The model is predicting. Why this model is predicting or giving rise to this output? What was the reason for the occurrence of X or the output? What would happen if Y was the cause of the occurrence of X? What variables influence the user decision most? What if the information is altered? To keep current results, what criteria must be met? Is there anything that can be done to have a different outcome? Why is it essential to make a certain conclusions or decisions? So these are the few questions that has to be asked to the model to understand or to get a trust about the model. So one is called data explainability, model explainability as well as post-hoc explainability. So when we're understanding or when we're designing our models and understanding or getting the trust, basically we have to ask these questions. So there are large number of models people have used. Today morning, professor told there are some Lime models, GradCam plus. So there are different models also people are using, that is scope-based, model-based, complexity-based, as well as methodology-based models. And these models have been used to understand the explainability as well as interpretability of the models. So we'll talk one of the example of this explainable AI for ECG for identifying heart or cardiac disorders. So before us understanding this, how we have used explainable AI for analyzing the cardiac disorders, first we should understand our past paper which already we have published and how this cardiac disorder can be identified. So before coming to this model as well as the technique, first I should explain what exactly this ECG represent. This ECG stands for electrocardiogram. It is nothing but a non-invasive, inexpensive, cost-effective, affordable, and easily available penless representation or penless technique to represent the heart functions. Basically, this ECG represents the electrical activity of the heart, and which is represented by a graphical representation. If you look into a conventional ECG representations, basically we are using 12 conventional ECG leads to record the ECG signals, out of which 6 are limb leads and 6 are chest leads. So if you look into the ECG signal, a typical ECG signal for a normal human being consists of P, Q, R, S as well as T waveforms, or you can say that PQRST. So this PQRST has a different significance. Basically, P represent atrial depolarization, and QRS represent ventricular depolarization, S represent negative deflection after R wave, STTU, this is ventricular repolarizations. So these different that means a different waveforms has a different significance, and whenever these parameters are changed, it will give rise to certain disease conditions. And for a normal human being, these are the certain durations as well as the parameters have been represented. So now we are trying to extract the ECG signals, and these ECG signals is to be used for analyzing the heart conditions. Why this heart signal is very much important? The reason behind is that this heart signal can be easily captured by the help of wristbands or very low cost sensors. So that's why I told in the first of my slides that there is certain cycles, that is MAPE cycle or MAP cycle has been used. So this can be easily captured by the sensors, and it helps to analyze the signal more quickly as compared to the images. And this is aided by this comprehensive sensing, machine learning as well as deep learning. So healthcare providers are trust with the decision of this AI, so that we have to develop a model which can be easily interpretable as well as explainable. So already we have discussed these slides. I'm just skipping this. So now there are many works people have done for ECG analysis. So when here we are talking about to analyzing the heart disorders, how we can analyze the signals of ECG signals. Basically, if we look into the literature, so mainly researchers are using pre-processing, feature extraction, as well as classifications. So in pre-processing, there are a variety kind of things have been used, that is removal of artifacts, removal of noises, etc. In feature extraction, there are different kind of features have been extracted: time domain features, frequency domain feature, time frequency analysis features, etc. And these features have been used in case of machine learning as well as deep learning to identifying the different cardiovascular diseases. So when we're talking about the features, these features can be of traditional machine learning approaches features like Fourier transform, Godlage higher order statistics, structural co-occurrence matrix features fed to these classifiers to do the classifications. So this is the standard procedure that has been followed by the different researchers to analysis the ECG signal. That is the first is the pre-processing step, feature extraction, and classification. Some of the researchers have been used the feature selection technique to select which features are best suitable for performing a task or the classifications. These are some of the techniques have been represented. I'm not going through these techniques. We'll just directly go to our method. So what exactly we are basically doing in our work? We have identified atrial fibrillations from the ECG signals. And what exactly this atrial fibrillation? This atrial fibrillation represent one cardiac conditions which result in inadequate blood flow, abnormal in ECG recordings, blood that means this age occurs due to the blood clotting as well as strokes. And this AF can be categorized by irregular and often rapid by rapid heart rate. So that means irregular and rapid heart rate, we can able to identify AF occurs in the upper chamber of the heart, and the region of this AF is due to the disorganization of electrical signal. We'll understand what exactly the disorganization of the electrical signals. Basically, the electrical signal, it starts from the right atrium, that is known as the sinoatrial node, and this is transferred to the AV node. Then it will come to the bundle of Hughes, and next is to the Purkinje fibers. Due to the motion or due to the travel of the electrical signal from the SA node to the AV node, bundle of Hughes and Purkinje fibers, the contraction of the heart, that is atrium and ventricular occurs, and due to that the flow of blood occurs. And we are basically capturing the ECG signal, that is the electrical activity of the heart. So this is the representation in case of a normal human being. But a person having the atrial fibrillation, these impulses which is starting from the sinoatrial node, they are collapsed inside this atria, and they are not traveling directly to this AV node. They are collapsed inside this atria, and the signals not transmitted to the AV node uniformly. So this is basically represented as plumbing of blood to the lower chamber is disturbed. So that means the blood which is coming of the atrial to the ventricle is basically get disturbed. And due to these disturbances, the P wave is missing, or there is some irregular that is distances present between the RR. So that means known as the RR interval basically varies. So this is known as the atrial fibrillations. And this atrial fibrillation we have to identify from the ECG signal. That is our work. And in this case, we are looking into the three types of atrial fibrillation. One is known as the paroxysmal, persistent, and permanent. The paroxysmal basically lasts from 30 minutes to 7 days, and this type of atrial fibrillation stops by its own, whereas the persistent remains more than the 7 days, and permanent, it is a long-term conditions, and it is a continuous. So the symptoms that is associated with the atrial fibrillations are known as the palpitations, shortness of breath, fatigue, dizziness, chest pain or discomfort, lightheadedness, or known as the fainting. And this atrial fibrillation occurs due to many factors that is known as the high blood pressure, heart diseases, thyroid problems, stress, obesity, sleep apnea, lung diseases, as well as excessive alcohol or caffeine consumptions. So now, how we can able to identify this AF? So as already we have told that this AF is nothing but a regular rhythm. That means RR interval varies. There is an absence of P wave. There is no proper atrial depolarization occurs. That means P wave is basically represent to the atrial depolarization, and in case of AF, this P wave is not present, and it leads to rapid ventricular response, increased heart rate, irregular in QRS complex, and AF episode durations. So this information has to be analyzed to identify whether a person is having the AF or not having the AF. So we are taking the ECG signals. So this diagram represent the block for identification of this AF. The ECG signal has been considered. This ECG signal is passed into the pre-processing block, which consists of a mean subtraction as well as Butterworth filtering. And this filtered signal is used for extracting the various features by various techniques like AR, entropy, wavelet, as well as statistical features, and these statistical features are used by SPM as well as KNN classifier to classify them whether the ECG signal is with AF or without AF. And the performance of this model is evaluated by accuracy F1 score as well as MCC, and the output have been represented here. So this is the simplest representation of this AF identification. So input EC signal is considered, passed into the pre-processing block, which is consists of mean subtraction, filtering, as well as augmentations. Today morning, professor told that in biomedical signal processing, augmentation is not a good idea to use it. So here we are using a different augmentation that is known as addition of noise, whether to check whether our model is robust to this robust or not. So in this case, we are using only noises, not any kind of augmentation we have done, only addition of noise. Feature extraction is performed by entropy wavelets as well as statistical features, and classification is done by support vector machine as well as k nearest neighborhood classifier. And the performance is evaluated by accuracy F1 score as well as MCC. So in pre-processing, basically the model is used to overcome the noise as well as the artifacts. It is done by the mean subtraction, and it provides numerical stability, gradient distance convergence, and it provides normalizations. It can easily interpret the model. So how this mean subtraction is done? It is done by the cross correlation with a unity kernel and dividing by its length of the kernel. The mathematical representation is represented here. After this mean subtraction, a Butterworth filter of order 5 and cutoff frequency of 1000 has been used to filter the signal. The lower order Butterworth filters are not sufficient to provide satisfactory results. Whereas in case of higher orders, there is a phase shift was observed. So in order to overcome that trade-off, that means we are using the order of the filter to be 5. It should not be very high or it should not be very low. And sometimes we have used Chebyshev filter as well as type 1 and type 2 for better roll-off, which suffering from ripples and distortion in some cases. So if we look into the Butterworth filter, Chebyshev type 1 and type 2 filters, the Butterworth filter of order 5 is a good choice for filtering the ECG signal because it is not so low, as well as this order is not so high. And so this is the reason why the Butterworth filter is used. So this is the original ECG signal, this is the filtered ECG signal, and this is the, as we are saying, this is the signal which is added with a Gaussian white noise to increase the number of signals present in the databases. Here the different feature extraction technique have been used. One is wavelet, entropy, as well as statistical features. Under wavelet, Dobbesis, Coeft, Fischer-Koevin, Haar, and Simlet wavelets have been used to extract the features. In case of entropy, Shannon, sample, approximation, conditional, permutation, entropy have been used, and statistical mean, standard deviation, skewness, kurtosis, as well as RMS features have been used. So this wavelet provides the better localizations, which is non-linear, non-stationary, for time, as well as it can be used for time varying signals like ECG. So here we are using a different mother wavelet to identify the wavelet features. And in case of entropy features, which basically measures the irregularity, non-negative, and 0 for periodic variations, and large value represent for the randomness. Different features, different entropies such as Shannon entropy, sample entropy, approximation entropy, conditional entropy, as well as permutation entropy have been used for calculating these entropy features. Here the mathematical representation have been represented. I'm just skipping these slides. Next, different statistical features have been used, such as the mean, average, standard deviation, skewness, kurtosis, as well as root mean squares. So these standard deviation features, entropy features, and wavelet features have been used by the classifiers. One is support vector machine as well as k nearest neighborhood classifiers to do the classifications. And in this case, in case of KNN classifiers, which is nothing but to perform the work of classification as well as regressions, and this k nearest neighborhood, k smooths the boundary, leads to a misclassification for noisy as well as overlapping classes. For small k, this complex decision boundary and improves model sensitivity, so it is adjusted suitably. So in this case, the database that have been used is known as the PF prediction challenge database, MIT BH AF database, intracardiac as well as AF termination database, long-term AF database, AF termination ECG databases. If you look into the databases, in PF there are only 2 classes, whereas in other classes there are more than 2 classes are present. So the PF database consists of 200 signals each that means each class consists of 100 signals, and they are having the length of 38,400 as well as 230,400. So that means each sample or each signal consists of two length of the signals. So we are using all the length of, that means the whole length of the signal to analyze whether this AF is present or not. So the result is represented in the form of a table. The basically it is represented by the training accuracy and testing accuracy for different mother wavelets, as well as different entropy features, as well as the statistical features. So in this case, the highest training as well as testing accuracy that we are getting is 91.88% by FK6 similar 12 as well as HAR wavelet. So this is the highest accuracy that we are getting in this case. And if you look into the combination of the different mother wavelets, we are improving the accuracy. So for that reason, we are combining the different wavelets, and the training as well as testing accuracy have been computed. So if we'll compare our method to the existing methods, then we found that the wavelet features with SVM classifier provide the accuracy of 91.88%, whereas the ensemble of the wavelet features with SVM classifier provides 91.90%, and entropy features with support vector machine and entropy features with KNN classifiers provide 100%, and that same is obtained for the statistical features. So what we understood from this classification is that entropy and statistical features with SVM attended 100% accuracy, and sample and spectral entropy features perform better among the entropy features. Today morning, professor told that we have to use a light network, that is a less number of layers to be used for whenever the database is very, very low, and whenever the database is very, very high, you have to use the deep neural network architecture, that means a large network models. So here we have discussed about a simplest model, that how AF can be identified from the ECG signals. In the next part, we'll discuss that how this explainable AI is used in this model, that is the deep neural network model, to analyze the ECG signals. So if you have any queries, you can please ask so that we can have a discussion, or otherwise we can have a lunch break, and we'll join at 1:30 to discuss about that how this same digit AF can be identified from the ECG signal by using the deep neural network models, as well as how explainability AI can give a trust to the models. So yes, please audiences, if you have any queries, please free to ask. Unmute your mic as well as on your camera and ask the questions so that we can have a discussion. Let me see any queries from the participants in the chat box. Yeah, I'm stop presenting. So yes, any queries?
Hello. Sir, am I audible?
So I'm just seeing the chat box. There is no question in the chat box. Yes, Miss Dr. Pooja Soni. On what factors does the choice of wavelets depend? Yes, Minister, can you, Dr. Pooja, can you explain this question more elaborately? Basically, wavelet is used for time frequency analysis, and basically not stationary non-linear signals. We are using the wavelets to understand the localization both in time domain as well as frequency domain. Let me to finish Dr. Pooja's question. So if you look into the wavelet, that means it is nothing but a time frequency analysis. It can localize the signal both in time domain as well as frequency domain. What exactly this localization? Why we are going for this wavelet? Because if you look into the ECG signal, it is a non-linear signal as well as it is regular with varying. Regular with varying means suppose I am sitting, my ECG signal is uniform, that is RR interval is uniform, I am a healthy person, RR interval is uniform. So if I will stand up from here and do some physical exercise, and again I will come and sit here and take my ECG signal. So it is irregular. That means the same P, Q, R, S, T waveforms are present, but the intervals are varying. That is regular. We can say that it is regular and not uniform in nature. Regular. So what exactly? This is nothing but a non-linear as well as time varying in nature signals. So whenever there is a nonlinear time varying nature of signal is present, this wavelet transform provides the coefficients related to the variations present in the ECG signals. Because what the variation is happening? So initially the RR interval is something, now the RR interval is changed. This is the variation. So how we can able to capture the variations? So that can be easily identified or easily can be captured by the wavelet, because the wavelets are used the small waves to identify the variations. So if you look into the factors, means as Pooja has asked, that means what exactly the factors to choice of the wavelets. So we are using a DB4 in this case, and the reason of DB4 of using this case is that as a DB4 or DB5 or DB6, basically this represent the movement of these signals. So for that reason, we are using this wavelets, and DB4 is the best choice for these medical signals, because already people have found a good result for the ECG signals for this DB4 wavelet, and that's why we are going DB4. And in case of many medical signal image processing, also DB4 is used, because the DB4 has the cross section that is distribution is similar to the DB4 wavelets. So that's why there is a choice of a DB4 for this ECG signal. I hope it is clear to you that why this or how we can able to select the wavelet in case of analysis. But in our cases, what we did, we are taking each and individual wavelets and we are seeing that how these features are basically performing to the classification accuracy. So that means all the wavelet features have been collected and all the wavelet features have been used by the classifier to do the classification. And based on that, we are selecting that which wavelet is the best choice. That is the one option that we are selecting the wavelets. And the second option is that if you look into the literature, many researchers have used DB4 wavelet, HAR wavelet, because of this good performance, and this is one of the second choice. So this is the reason that how, or this is the factors that how we have selected the wavelet. I hope I have cleared our question. Next, I am going to the next question, which is given by Dr. Sayali Saket. Can you discuss some for images like detection? Yes, this same thing is performed in case of detection of images. Already we have performed some of this research related to skin cancer detection as well as the breast cancer detection. You can have look into my homepage and you can get the details about the techniques. And if you can ask more detail that what exactly you want to know about the images detection, then I can able to clarify your doubt, Ms. Sayali. Next is it is one question is asked by Savitri. Could you please discuss how to visualize the features generated by CNN for 1D signals with explainable AI? Yes, sir. We'll discuss this thing in our next session, that how we can visualize the features generated by CNN for 1D signals. One of the most better example is TSNE plot. The TSNE plot says that how we can able to visualize the features. Next, Pooja is asking, yes, sir, in case of images based processing like the skin cancer, how can decide to go for which type of wavelets to explore the temporal development and localization of artifacts? Yes, already I told in ECG, we have analyzed each and individual wavelets to see the classification accuracy. And if you look into the literatures, many researchers have used DB4, and the explanation they have given is that the DB4 has the cross section, that means the image cross sections or the area of region of interest cross section has a similar distribution of this wavelet. So that's why they are using this wavelet. So these are the region that how we can able to select the wavelets. Next question is yes, Savitri. Yeah, any no more questions from your side? I hope I have clarified the questions raised by the participants. And there are some questions which is asked by Savitri, that how we can able to see the features. That is the TSNE plot. I will show this TSNE plot after the launch. We'll meet after the launch at 2 o'clock. So I welcome you once again at 2 o'clock for the next half of this presentation. That how explainability can be discussed in of the for the same AF identifications. In that case, we'll discuss about the TSNE plot also. Thank you.
Hello, sir. I have one doubt. Yes. Hello. Sir, can you explain with regard to image processing?
Meeting here.
GradCam line.
We can join at sharp 2
GradCam
o'clock.
line. GradCam line.
Use it.